A very good afternoon to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering, and I'll be dealing with the subject robotics in Institute of Aeronautical Engineering for mechanical students. And my today's topic is problem solving on robotics subject. Right? And my today's topic is problem solving in the robotics subject. Now let us consider one of the case study in the robotics considering the vector and the origins. That is, for example, we have two coordinate frames 1 and 2 which are initially coincident, where the frame 2 is in rotation with 450 degrees about a vector k which is having 0.5, 0.866 and 0.707 power t transfers passing through the origin. Determine the new description of frame 2. Initially, the frame 2 is rotating at 450 degrees. We need to determine the new description of this particular frame 2. Right? That is, this is not 450, it is 45 degrees. Right? So here, the frame 2 is rotating at an angle of 45 degrees. We need to determine at what angle it is newly described. Right? Here we will be writing the vector k as 0.5, 0.86 and 0.707. Right? We will be writing the vector k in the form of a single matrix 0.50, 0.866 and 0.707. Now here, as per the rotational matrix or Rodriguez rotational formula, we determine the rotational matrix R with respect to angle theta as R is equal to 1 plus sine theta of the vector k plus 1 minus cos theta square of vector, that is k square, where I is the here this is I, where I is the identity matrix, theta is the angle and k is the cross-sectional product matrix of k, that is this particular k, vector k. Right? Capital K is nothing but the cross product matrix of the vector k. Now, firstly, we will normalize the vector k as we have written k is equal to 0.5, 0.866 into 0.707. Now, we will normalize this particular vector k as like this. Right? Vector k will be written like this, where it is taken as, because it was k square. Right? So, k is equal to 0.5 square plus 0.866 square plus 0.707 square. Right? We will normalize the vector k in such a way that it is taking the square root of 0.5 square plus 0.866 square plus 0.707 square. Now, what will we get? What is 0.5 square? It is nothing but 0.25. Plus, what is the square of 0.866? It is 0.749 and 0.499. Now, when we add all these particular constraints, what are we getting? Root of 1.499, which is appropriately equal to 1.22. That is, the square of 1.449 is nothing but approximately 1.22. Now, this particular vector k, when we consider it with the formula, we will be writing 1.1224 into 0.5, 0.866, 0.707 will be equal to 0.4082, 0.70711 and 0.5773. Right? Now, this particular vector k, when we are normalizing, we have written it as the square of 0.5 square plus 0.86 square plus 0.7. Altogether, approximately, we have got 1.22. Now, as per the equation, that is k is equal to 1 by this particular 1.22 into this particular k, that is the vector k. We have got this particular matrix. Now, we need to calculate the cross product. What is the cross product? It is nothing but capital K, right? We need to calculate the cross product matrix for unit vector, right? We need to find out the cross product, that is capital K, for the unit vector. Now, how will we find out that capital K? Capital K is nothing but 0 minus kz, ky, kz 0 minus kx, or minus ky, kx and 0. This is the matrix for the cross product capital K for a single unit vector. Now, how we need to insert all these values in this matrix? So, what will we get? 0. What is kx? Kz minus 0.577, right? And ky is 0.70711. This one, kx, ky and kz, right? And 0, what is kz? 0.577. 0, what is kx? It is nothing but minus 0.4082. Minus, what is ky? 0.70711. Kx is 0.408 and again 0, right? So, this is the matrix which we have got for a cross product K for a unit vector. This is how we have calculated capital K. Now, we have the angle as 45 degrees given in the question. As per the question, there was an angle of 45 degrees being given, where when we need to convert this angle into radians, it is nothing but pi by 4 radians, right? When we need to convert this particular angle 45 degrees into radians, we will be converting it into pi by 4 radians. Now, we need to compensate this particular sine theta, cos theta as sine of pi by 4, which will be nothing but root 2 by 2, or cos of pi by 4, which is nothing but root 2 by 2 again, right? As since we have taken theta as radians, that is pi by 4, we have got sine theta as root 2 by 2 and cos theta, that is cos pi by 2 in terms of radians, we have got root 2 by 2. Now, when we are considering, we need to commute it as sine theta of k is equal to root 2 by 2 into the k value. The k is nothing but 0, right? What is k? 0. This we have to write here. 0 minus 0.577, 0.707, 0.577, 0 minus 0.4082, minus 0.707, 0.408 and 0. This is the value of k which we have inserted here, right? The sine theta k is equal to root 2 by 2 into k. Now, when we are calculating this, what we are getting? Root 2 by 2 into 0 is 0. Root 2 by 2 into minus 0.577 is nothing but 0.408 into 0.5 into 0.408, 0 minus 0.288 This will be 0.5, 0.288 and 0. Right, this is the matrix which we have got for sine theta of k. Right, when the same matrix we calculate it with respect to cos theta, what we'll be getting? Cos theta of k is again root 2 by 2 into the same k. That is, what is the k value here? We have got 0 minus 0.577, 0.707, etc. So, when we are inserting cos theta of k with respect to root 2 by 2, here we will be getting a matrix called, this will be again 0, 0.517, 0.707, right? 0.5770 minus 0.4082 minus 0.707, 0.408 and 0. Now, when we are calculating this with this, we will be getting here, since here we have the cos as this particular term, here we need to calculate this particular constraint, that is 1 minus cos theta into k square. Here we have I plus sin theta k, so we have calculated sin theta with respect to the cross section of the unit vector. Right, here we need to calculate this particular term, that is 1 minus cos theta into k square. So that the same we need to represent it here. It is 1 minus cos theta into k square, right? That is into this particular square. So what will we get here? 1 minus root 2 by 2 into k square. What is k square? Minus 0.816, 0.4082, 0.2041, 0.4082, minus 0.5, 0.2886, 0.2041, 0.2886 and minus 0.33. Right? So, now with respect to this particular terms, we need to calculate the matrix. So, how will we calculate this particular matrix again? 1 minus root 2 by 2. This already we have written, right? So, 1 minus root 2 by 2 into this k. So, what we will be getting? 1 minus root 2 by 2 is nothing but approximately equal to 0.299, right? So, this 0.299 into this particular matrix, the same matrix. So, what will we get overall? What will the overall matrix be? Minus 0.239, 0.119 and 0.059, right? 0.119 minus 0.146 and 0.084. And the final matrix with respect to this third quadrant will 0.0597, 0.0845 and minus 0.097. This will be the final matrix for 1 minus cos theta whole power k square. Right? Now, we need to calculate R. That is, this particular R. We need to calculate the rotational matrix R. What is the formula for rotational matrix R? R is equal to I plus sin theta k. This we have calculated. And now, just now we have calculated this particular term. And what is I? We need to identity matrix, right? So, we need to calculate R. R is equal to I plus sin theta into k plus 1 minus cos theta into k square, right? So, what is identity matrix? Identity matrix is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the identity matrix as we all know. Plus, what is the sin theta we have got? This is the sin theta matrix which we have got. Insert this here. We will be inserting this here. So, what is it? 0 minus 0.408, 0.5, 0.408, 0 and minus 0.2886, and this will be minus 0.5, 0.2866 and 0, plus what is this 1 minus cos theta k square? This we have to insert here, that is minus 0.239, 0.11969 and 0.0597 into 0.119 minus 0.1464 and 0.084. This will be 0.0597, 0.0845 and minus 0.0976. Right? This is the rotational matrix which has been obtained. Now calculate the whole rotational matrix. What will we get? 1 minus 0.239 minus 0.408 plus this particular 0.199, 0.11969 and 0.5 plus 0.0597. Right? Again here 1 into 0.408. Right? 0.408 plus 0.119. 0 into 0, 0. So 0 minus the 0.1464. This 0, 0, this will become minus 0.2886 plus 0.084. Right? Again the third one will be, here this is 0, so minus 0.5 plus 0.0597 and this 0.286 plus 0.0845 and this is 0, so minus 0.0976. This will be the rotational matrix with respect to the identity matrix, the sin theta and the cos theta. With respect to identity matrix, sin theta and the cos theta, we have got this as the rotation matrix. Now again further solving it, what will we get? 1 minus 0.0, it is nothing but 0.761 minus 0.2885 and 0.559. Right? 0.4 plus 0.119, it is nothing but 0.5279 minus 0.14, this is 0, right? So it will be 0.1464 and this will be minus 0.0204. This will be minus 0.4402, 0.3732 and 0.0976. Right? So this is the rotational matrix with respect to this particular angles. Now, with an angle theta is equal to 45 degrees. Right? So, when we are considering the angle of 45 degrees, we need to find out the rotational matrix, where the rotational matrix was being given as identity matrix plus sin theta of k plus 1 minus theta into k square. Right? And the identity matrix is nothing but 1, 0, 0, 0, 1, 0 and 0, 0, 1. Finally, we have got this as the rotational matrix for an angle of 45 degrees, which we have considered it in the terms of radians, that is pi by 2. Right? Moving on to the second problem. Here again it is the frame problem. Right? That is, here we are considering frame 1 and 2, which have coincided origins, and this particular origins have difference only in one orientation. Right? So here the frame 2 is initially coincided with frame 1, where certain rotations are carried out about the axis of the fixed frame 1. First, the rotation about x-axis is 45 degrees and about y-axis it is 30 degrees. And finally about x-axis, it is 60 degrees of obtained, which is equivalent rotational matrix for R1 to 2, right? For R1 to 2. Now we need to find out again the rotational matrix here. So to obtain at an angle for the x-axis at 45 degrees, for x-axis at 45 degrees angle, the rotation matrix is nothing but 1 0 0 0 cos theta minus sin theta 0 sin theta and cos theta. This is a standard rotational matrix for for the x-axis. So when we are considering the x-axis an angle of 45 degrees, the rotational matrix is the standard, which is this one, 1 0 0 0 cos theta minus sin theta 0 sin theta and cos theta. So when we are substituting that in the matrix, what we have got, rotational matrix as 45 degrees is equal to 1 0 0 0 cos 45 minus sin 45. As we all know, cos 45 is nothing but root 2 by 2 and minus sin 45 is minus root 2 by 2, sin 45 root 2 by 2 and cos 45 root 2 by 2. Now the same thing with respect to y-axis we need to do. Now for y-axis, what is the angle? It is 30 degrees. So at y-axis the angle is 30 degrees. Now we need to calculate the rotational matrix with respect to y-axis. So with respect to y-axis, here this is the axis, right? X and y. At x-axis, what was that given? 1 0 0 0 theta theta and 0 theta theta, right? With respect to cos, sin, cos. This was for x-axis. In the same way, for y-axis, what is the rotational matrix? Cos theta 0 sin theta 0 1 0 minus sin theta 0 cos theta. So when we have to substitute the angles here, what we have got? Cos theta 0 sin theta 0 1 0 minus sin theta 0 cos theta. Substitute 30 degrees. Here for y-axis the angle is at 30 degrees and for x-axis the angle is at 45 degrees. So what we have got, rotational matrix at 30 degrees is, what is cos 30? Root 3 by 2. What is sin 30? It is 1 by 2. In the same way, for minus sin it is minus 1 by 2 and for cos theta it is root 3 by 2. Now, when we are rotating the same x-axis at 60 degrees, right? When we are rotating the same x-axis at 60 degrees, right? When we are rotating this x-axis at 60 degrees, what are we getting? We know the rotational matrix for x-axis, it is nothing but 1 0 0 0 cos theta minus sin theta 0 sin theta and cos theta. So at 60 degrees, what are we getting? What is cos 60? Cos 60 is 1 by 2 and minus sin 60 is minus root 3 by 2. In the same way here, sin 60 root 3 by 2 and cos 60 is 1 by 2. So the rotation matrix for 60 degrees is 1 0 0 0 1 by 2 minus root 3 by 2 0 root 3 by 2 and 1 by 2. Now when we are combining these rotational matrices, right? When we are combining these particular rotational matrices, we will be getting R1 is equal to, we are doing rotational matrix with respect to theta into the rotational matrix Y with respect to theta. So what is the theta with respect to x-axis? It is nothing but 45 degrees and with respect to y-axis, it is 30 degrees, right? So when we are combining both these angles, what we are getting? R1 is equal to, what is the x-axis matrix? Here we have got 1 0 0. This we need to substitute there. So it is 1 0 0 0 root 2 by 2 minus root 2 by 2 0 root 2 by 2 and root 2 by 2. And with respect to 30 degrees, the matrix is root 3 by 2 0 1 by 2 minus 1 by 2 0 root 3 by 2. Now we need to multiply this. So what we will be getting? R1 is equal to 1 into root 3 by 2 is nothing but root 3 by 2 into 0 and 0 plus 1 by 2 it is 1 by 2. 0 plus 0 0 root 2 by 2 minus root 3 by 2 root 2 minus root 2 by 2. This we will be getting minus 1 by 2 root minus 1 by 2 root 2 into root 2 by 2 into root 3 by 2 root 2 minus root 2 by 2. So this is the matrix which we will be getting when we combine both the x-axis and y-axis with respect to 45 degrees and 30 degrees. Now when we square the rotational matrix, what we will be getting? R1 into Rx of 60 degrees. Since we have the rotation of the x-axis with respect to 60 degrees also. So what we need to do? R1 square. R1 square is equal to R1 into R rotational matrix with respect to 60 degrees. So here what is R1? This we have already calculated. So this into this particular matrix which we are getting with respect to 60 degrees, right? So R1 square is equal to root 3 by 2, 0, 1 by 2, 1 by 2 root 2, root 2 by 2, root 3 by 2 root 2 minus root 2 by 2, and 1 by 2 root 2, root 2 by 2, root 3 by 2 root 2 minus root 2 by 2. So this is R1 matrix, right? This is R1 matrix. Now we will be writing Rx matrix with respect to angle. It is 1, 0, 0, 0, 1 by 2 minus root 3 by 2, 0, root 3 by 2 minus 1, plus 1 by 2. Now when we multiply, what we are getting? R1 square is equal to root 3 by 2, right, into 1 by 4 and root 3 by 4 plus 1 by 2, right? When we are multiplying, what we are getting? Root 3 by 2 into 1 by 4 to root 3 by 2 plus 1 by 2. Now this one is 1 by 2 root 2, right? 1 by root 2 into 1 by 2 minus root 3 by 2 root 2 into root 3 by 2, right? Right? What we will be getting for this here? Yes, what will we get for root 3 by 2 minus root 2 by 2 into 2 minus root 3 by 2? We will be getting root 3 by 2 root 2 into 1 by 2, right? Minus root 2 by 2 into root 3 by 2 plus 1 by root 2 into root 3 by 2, right? Now when we come across this matrix, it is the same. Minus 1 by 2 root 2, root 2 by 2 into 1 by 2 minus root 3 by 2 root 2 into root 3 by 2. Now root 3 by 2 root 2 into 1 by 2 minus root 2 by 2 into root 3 by 2, right? And the final one plus root 3 by 2 root 2 into 1 by 2, right? This will be the final matrix which we will be getting. Now this is called as R1 square is equal to R1 into Rx with respect to the 60 degrees. This is the rotational matrix which we will be getting, this is the rotational matrix which we will be getting in the final constraint, right? That is here what we need to find out. Our rotational matrix R1 square. We need to find out obtain the equivalent rotational matrix, that is R1 square. So this is the rotational matrix R1 square which we have got, that is R1 into Rx with respect to 60 degrees, right? And these are the references which we have gone through. So in today's class we have discussed about two rotational matrices problem with respect to the angles and x, y and z direction. So in the next class, we will be dealing with the next topic, that is fluid robotics and few problems related to matrices, right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.